Hey there, ready for another one? Oh, there you go. I'm going to start here now, learning module 4 of quantitative methods, probability trees and conditional expectations. Classic topic of quantitative methods, classic topics of statistics. So if you have taken statistics at one point of your life, in your career or academic studies, you probably have seen probability trees and conditional expectations. Okay, very well used in different sciences and different majors, right? So it's not only business which you will be presented to this topic. However, here we're going to focus obviously on probability trees and conditional expectations to solve business problems or to access some kind of returns or price of an asset, right? So that's why you're going to be using the probability trees in financial analysis. And you will also need to know the concept, right, or grasp the concept of conditional expectations, because you're going to see classic questions as well from financial analysis when quantitative methods focus on related to conditional expectations. So if this happens, what is the probability of something else to happen, right? So it's probably the probability of you getting a conditional expectation question on QM, in my opinion, is kind of high. That's a high probability. All right, well, let's go to the learning outcomes. Then you go to my points, and that's it. There's not much here, huh? We have probability trees, so I'm going to give an example, and the conditional expectations, conditional probabilities. We're going to give you a couple examples, and that's it. Then I ask you to practice at the ecosystem. The questions that you have there related to learning module 4, probability trees and conditional expectation. Now, let me actually tell the folks that are watching this video after 2024, okay? If you're watching this video and every now and then I mention material to 2024, but you are in 2025 watching this video, that's because the material has not changed, okay? The only thing that may have changed is the order of the learning modules, okay? But the learning modules per se, if has not changed from one year to another, the video will not be updated. This is the same content, all right? Good. So I'm glad this is clear. Let's go to the first slide here, and for the first learning outcomes. There you go. So look at that, 3 learning outcomes, right? Very quick. We're gonna need kind of like it's more like let's say learning outcome A. It's a review of the previous learning module, right? The statistical measure of assets returns, right? So variance, standard deviation, demonstrating the application of investment problems. The key elements for module 4 here, probability trees and conditional expectation, is formulate an investment problem, right, as a probability tree, and explain, right, how using the conditional probabilities you can actually solve that problem, right? So it's a very typical problem, the if this then that. If the demand is high, I'm gonna sell this much, but if the demand is not high, I'm gonna sell that much, right? What is the probability of the demand to be high, demand to be low, and then you orchestrate or organize that in a tree, and then you have to solve the tree with what you call backward induction, right? We're kind of backwards. We're going to go back to find the answer, okay? So that's important to understand how to set up a tree and how to solve the tree problem. In my opinion, in your exam, level 1, it's impossible to ask a tree. Impossible is a strong word, but I think it's very, very difficult that a question where you're going to have to create the tree. And then you got alternative A, they give you the drawing of a tree, and then B and C, and then you have to choose the which one. You know what I mean? It's not feasible to ask for you to prepare a tree for the exam. However, it's more likely that you're going to get a question or you're going to have to solve the tree, the problem. It's that's kind of like presented on a probability tree format. Learning outcome C, calculate. See, now here is the calculate and interpret updated probability in investment using the BICE formula. That's a very important formula in financial analysis. The formula of Bayes is the formula, or is the equation, I guess, right? Is the identity that tells you that giving an event, right? That's what is the probability of another event to happen. However, it's based on conditional probabilities. Okay, I'm gonna try to show here for you exactly the difference between the formula, the Bayes formula, and the conditional probability formula. So I want you to see the elements of each one, so it's gonna be easier for you to memorize. Now, in my opinion, if you have to use the Bayes formula in the exam, will be given in the question of the exam, use the Bayes formula here. Okay, the name B-A-Y-E apostrophe S, or S apostrophe, because his name has finished with an S, that will be specified in the problem. So you don't need to kind of like, oh my God, should I use the Bayes formula here? Should I use the conditional probability formula? No. If it's the Bayes formula, will be given in the problem. That's my expectation, and I'm telling you this because it's based on mock exams, official mock exams. Those questions, they tell you to use that formula. Right, so I wouldn't be worried about if I have to use that formula, right, or when, but it's more like if the problem asks me to, would I be able to use the formula? That's the key here. All right, let's see the next one here, which is kind of like a summary, because I said to you it's a short video here, short learning module. So again, expected value and variance is back, but again, we already spoke about expected value and variance on the previous learning module, so I'm not going to stress that on this video here. Probability trees, yes. Conditional expectation, absolutely. Right? The probability rule and expected value, that's we're going to show it to you solving a tree problem and an example. The Bayes formula and updating formula, probability estimates, and the Bayes formulas itself, we're going to show it to you again, an example on how to use. Okay? My expectation is that the Bayes formulas, if show up in your exam, it's mostly the probability that you will face, that you will get a Bayes formula in your exam is high. However, I don't think that's every single level 1 exam in February 2024 or August 2024 or whatever year or whatever window this exam is going to take place that will get a Bayes formula in the exam. Right? Remember what I said before, right? There are several exams that are going to be given at the same time, right? Or in a week of the exams. We're going to have to create several different exams. So one exam might have a Bayes formula, another one might have a different one, another one may not have. I don't know. But it's reasonable to expect that would be there. Okay? All right. So let me start here with my points here. I want to show, before I start, right, revealing and showing the examples, let me show it to you all the learning modules that you need to know for the 2024. And again, if you repeat this, nothing changed for 2025, then we're going to be using the same video. What I usually do when I start another year, it's start with a introductory video explaining to you, say, listen, the materials that have not changed are such, such, and such. Therefore, those videos are going to have some kind of content that seems like from a previous year, but the material is the same. In any new updated topic, we will prepare a new video. That's the case here right now. All of those videos of quantitative methods that you're seeing here are new because the quantitative method material, as you can see here, has changed quite a lot compared with the previous exam. However, change quite a lot is not fair because most of those topics were included on the previous exam. However, they divided differently now. They organized in 11 modules, right? 11 lessons. And the previous exam had 8, right? So it's kind of like more condensed, the material. Now it's more spread, more focused. I like it more the way that the material is organized now. So anyway, this is the learning modules 1, 2, and 3 that we already covered in the previous videos. Now we are on learning module 4, and then we're going to conclude quantitative methods review with the learning module 11. Introduction to Big Data. Okay, that's the last video. All right, so I want you to have an idea how this works. I'll be doing this for every topic. So when we start economics, guess what? I'm going to show you. Oh, it's out of focus here. I'm going to show it to you what you need to know from economics, right? But right now we are in quantitative methods, so we're going to be focused on that. So that's how I like to do. I like you to have an idea of all the learning, all the lessons that you need to know, right? And then go one by one. Good? All right. So now let's go and do a review on the probability trees and conditional expectations. I hope I can do a good job here giving you the most important points. I would definitely expect numerical questions here. Yes, we could. They could ask you some conceptual questions, absolutely. But I think most likely here, the idea is that you demonstrate that you understand conditional probability by performing, by answering questions, right? Numerical questions, I meant. So here are the learning outcomes we already did. The key points we already did. So let's go to an example. There you go. Practice 1. Probability trees and conditional expectation and the total probability rule for expected value. So look at that. I have here for you, okay, some important concepts related to joint and conditional probability. And I'm going to go over this, okay? And then I'm going to show you how to do a tree problem. Now we're going to do a very simple problem, tree problem. I don't expect you're going to get something super complicated in the exam anyway. And then we're going to finish the lecture, okay, or this video, with the Bayes, the formula of Bayes. So kind of like explaining to you how to solve a problem, how to approach a problem that you're going to have to use the formula of Bayes. It's not a complicated scenario, although it might intimidate a lot of candidates, because that's what I hear from candidates that talk to me, that they kind of like, really, I don't really get it. I don't really get that Bayes formula. So what I'm going to try to do here is kind of like make you get it, right? So make it probably easier for you than to answer the question in the exam related to it. Okay? All right, that's it. That's all we have in the agenda. So let's go. Let's go to the first problem. The first topic here, the practice. Let's talk about joint and conditional probabilities. Let's talk about that, right? So let's talk about the independent-dependent events. So look at that, okay? If the events are independent, the probability of them to happen together is just the multiplication of each individual probability, okay? Classic example, it's if you want to draw numbers, right? For a particular lottery or something like that, right? So you take the first number, then you take a second one, a third one, fourth, five, as many as that game allows you. Let's say 5 numbers. So you need, what is the probability of taking one, and what is the probability to take the second one, the third one, and then you multiply all those probabilities, because the key element here, and I think that's very helpful when you think that way, is that I need one and to the second one and the third one and the fourth and the fifth number. I need all 5. Just one doesn't help. One or another doesn't help me. It's one and the other and. So that's what we call the joint probability, the probability of both happen, both events, in this case, A, B. Could be several events, of course. Probability of A, B, C, D, sure. The probability of A and B and C and D happen at the same event. So you multiply those probabilities. Now, if the events are dependent of one another, so if I take this one, will interfere on what's going to happen on the next one, right? So there's a dependence. So if this happens, then there's more chance of something else to happen, or vice versa, right? So there's a dependence of events. Then the formula changes slightly and becomes the probability of A given B. That's what that slash means, right? It's supposed to be like a more vertical, but I could not find one here on my keyboard. So I'm putting this one here, right? So A given B. It's not A divided by B, okay? It's A given B times probability of B. So the probability of both events they're dependent to happen, it's influenced by the conditional probability. The one that has the given that is a conditional probability. Now, what I'm going to ask you to do immediately, okay, is to change how you see this formula here. Right? I don't want you to see the formula of the dependent as P of the joint equals P of the conditional times PB. No, I want you to organize in a different way, okay? So I'm going to kind of like show here how I like to organize that formula, right? I like to kind of change a little bit the order, okay, on here. So take a look. I'm going to isolate the probability of A given B. Okay, so the P of A given B, I'm going to do equal, and then I'm going to take, look at that, I'm going to take the PB that's multiplying here, and I'm going to throw under the PAB on the other side, right? So it's going to be P of both divided by P of B, okay? I would like, let me actually make it more distinctive here so you can see it. There you go. I would prefer you memorize the formula like that. Okay? So the probability of the conditional or the conditional probability equals the probability of the joint divided by the probability of the second one, right? The one that you want to find. Because A here is given, you want a probability of A. So the given B, you have to divide it by the probability of the given, right? That's scenario that has happened, okay? So that's how I would find it easier for you to remember, okay? Now, let's see something here to kind of like help, in my opinion, to understand this. So take a look. I prepared a little table for you here, okay? So the idea, okay, is to find the conditional probabilities. But let's talk about like events that has they call joint events, events that happen together or combine, or the both. What is the probability of both happening, right? So for example, if the question is not asking you for the formula, the Bayes formula, okay, just the conditional probability. Like say, for example, what is the probability of, in this case I have good credit, it's expressed by GC, and bad credit is expressed by BC. Good credit, bad credit, and then survive and not survive a recession. So, if the company has good credit, and survive a recession, or if the company has good credit but does not survive a recession, and here bad credit surviving, bad credit not surviving. Okay? Now, when you approach a problem like that in the exam, try to have this in mind. Try to see if you can organize that way. Okay? And see how many probabilities are given on the exam. Okay? So you usually have 3 probabilities given on the exam, like those 3 that I'm highlighting. No, not the 100% here. Let's remove the 100. Just those 3 there. Okay? So let's see if you can understand what they mean. So what is the 12% that's in this table here? Ask yourself. Is BC and survive? Look at that. Bad credit and survive, 12%. Okay? Bad credit. That's a joint probability. That's a probability of BC and S. A and B, no? BC and S happening. Huh? Now, what is the 80% right here? 80% is the line that you have here. The 80% is then what we call the joint probability, or total probability. In that total probability, friends, okay, this 80%, it's what? Is the total probability of good credit. Okay? Companies that have good credit, total, look at that, 80%. That's what's written here. Okay? So what is your conclusion about companies that total bad credit, according to this example? Well, it has to be 20%. Okay? Because the total has to be 100%. Look at that. Right? So I'm completing the table using here some logic, right? So look at that, 80 plus 20, 100. So now I know the total here. What is the total on this green box that I'm highlighting here? Is the total probability of survival. So who can survive or what is the percentage of survivors, companies that survive a recession, right? Well, it has to be what? It has to be 82%, right? Because 82 plus 18, it's 100%. So put it there, 82%. Okay? Well, think with me now, friends. If the total probability of survival is 82%, survive a recession, 82%, and companies have bad credit, good credit, if 12% of the bad credit survive, what is my conclusion? Well, that's 70%, excuse me, of the companies with good credit will survive. So good credit and survive. That's a joint probability. All right, now it's easy to get the next one. So what is the probability of having good credit and not survive? It has to be 10%. Right? And then, obviously, right, 8% is the probability of having bad credit, okay, and not survive, okay, and bad credit and survive. It seems illogical, but in real life, it's actually more likely that a company will survive even if it has bad credit. So why those numbers are the way it is. But we're not going to question that. Great. Now that I completed this little table here, is making my life much easier to compute the conditional probabilities. Think about that, right? Now, what is the probability of good credit and survive? Just take a look at the table. Good credit and survive, 70%. What about good credit and not survive? We got there, 10%. Okay? Bad credit and not survive, 8%. Perfect. There you go. Okay? That's going to be extremely useful for the conditional probabilities. Because take a look now. I wanted the probability that the company has, given that the company has good credit, given. It's not and, it's given. Now we know, we have a new information, okay? Now we know that the company has good credit. Now I want to know, okay, given that the good credit is in place, what is the probability of survival? It's not the same as asking what is the probability of having good credit and survive, okay? Different than that. So what you're going to have to do here is probability of given, has good credit and given good credit that to survive, okay? Probability of having good credit given that the company survived the recession is what? I have to remember that formula that I showed you before. The probability of both, right? That's the E in this, and here in the middle. Probability of good credit and survivor divided by probability of survivor, right? That's what we have there. So let's see how much we get there. So let's follow me here. Probability of GC, good credit and survivor. I have to go and look it down here. Look at that. Good credit and survive. It's 70%. Okay, 70%. Put it there. And then I'm going to have to divide. Take a look for PS. Probability of survive. What is the probability of survived? Okay, 82%. Take a look. Survive is 82%. So I'm just going to divide it by 82%. And then I got 85.4%. Let me round it here. 85.4%. Okay, that would be the make it a little bit more visible. There you go. 85.4%. See, not that complicated, right? Now you can do the other one as well, right? Probability of survival given that has good credit, which is the opposite, right? So it's again, right? The probability of both divided by the probability of having good credit, right? So probability of G and S combined. How much is the probability of, look at that, given good credit and survive is again the 70%. And the probability of good credit is 80%, right? So the answer here will be equal to 70% divided by 80%. 0.7 divided by 0.8. There you go. 87.5%. Okay? So, again, right, it's important that you get this logic, right? This mechanism here. Okay? Understand. Let's put this in decimal, in percent, excuse me. That'd be better. There you go. Okay? And you can do that using this concept of the table. That's the joint probability table. Joint. From the joint, I can find the conditional. All right? Good. I hope this was helpful, because understanding this concept that I just explained here will make easier for you, in my opinion, understand the formula of Bayes, or the Bayes formula, which is the one we're going to see now. All right. So before we go to the formula of Bayes, let's go very quickly here to show to you how to solve a probability tree. Okay, it's very simple, it's very intuitive. I'm not going to spend much time here. You're going to have plenty of time to practice this yourselves, right? And I strongly recommend that you understand how to do it. I do not, and that's my opinion, predict that the question of this, the tree itself, will be on quantitative methods. It's more likely that you get a tree on fixed income, because when you arrive on fixed income, okay, you're gonna get it that there's some ways that you can find the price of a bond using interest rate trees. Okay, it's a little bit more level 2 concept, but it might show up at least the question, conceptual question about that on level 1. Okay, one is, I think it's very likely you get something related to the tree. It's on the option pricing, right? The price of options, right? Because the price of options, we're going to use level 1, use the binomial approach to find the price of an option. Okay, level 2, going to use the binomial as well, but also the Black-Scholes-Merton model. Okay, but level 1 is going to focus on the binomial model. So it's a good idea to grasp that. All right. So now let's see how this is done. So what you're going to do is, once you have the numbers on your tree, you're going to go backwards, right? So you're going to find this. Look at that. I have 2 numbers, okay, that belongs to this branch here. Look at this. This branch here, let's say I don't have a number there, okay? Okay, this branch is empty, okay? Empty. So what is the number that I put it there, right? What is, because I don't have to keep on bringing those numbers. So what is the number that I put it there? So is the weighted average of those 2 numbers here, because they have 2 branches linking to that box. So I have to average those 2 numbers and put in that box. Same thing here. I have to average those 2 numbers and put it in that box here. Okay? And the average is not a simple average, right? It's a weighted average, and the weight is in the branch. So look at that. 200 times 60% plus 180 times 40% is the number that I put in that box. Same here. Look, 100 times 0.7, right? And 80 times 0.3. You add those 2, okay? And you get that total. So here we got 192 and 94. Great. Then, again, you repeat the process here. Okay, they repeat the process. Okay. And then 192 and the 94, you have to average those 2 numbers to put in this rectangle answer here. Okay, so this has probability of 60% of happening, and the 94 has a probability of 0.4% of happening. You do the average, weighted average, and you get 153. That's the there you go, put it there, and that will be the answer for this problem. Okay, an investment that gives the payoffs of 200, 180, or 100 or 80 with those probabilities, right, will be a fair price to pay today, 153 monies, right? Whatever currency you're using here. That's it. And it's not going to be more difficult than that on level 1 CFA exam. Okay, 1.5 minutes. You're not going to get a probability tree problems, would you have to set up the tree and then solve the tree. That takes more than 1.5 minutes. Okay, there's no way that you can design or draw a tree. So you maybe maybe gonna get a quick question, or you're gonna have to do the 3 and a piece of paper that you can get access to during the exam, right? And then find the answer, maybe. But I think it's going to be something quick, not something that's going to take a long time. For example, imagine usually when I taught universities the topics of probability trees, we usually give a case study, a long case study with a lot of little things, you know, if it is this, then that, and then if that, and then we have several branches and become something like, right, very complex. It's out of the scope here. We don't have time on the CFA level 1 exam to do something that complicated. Then you come to me and say, well, but in the ecosystem, I've seen a very, 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 very complicated question related to the probability trees. And I would say, yes, I agree with you, but that's the ecosystem. Now, that's maybe a mock exam that you see something like that, but that's not the exam. The exam is a minute and a half. It's going to be a much straightforward type of questions that you should expect there. Okay, good. Well, let's move on to the last topic of the day here, of the class or the video here, right? Which is, okay, friends, now let's see here now the practice 2 here, talk about Bayes form. I'm going to give an example here for you, how to understand when to use the conditional probability formula and when to use the Bayes formula. So take a look. First of all, let me show you here the conditional probability formula and the Bayes formula. I'm going to highlight that in red so you can see both at the same time. Just focus on those forms. The first one is the formula Bayes. Second one is the conditional probability. Try to see the similarities and the differences. So they're both asking you to calculate a conditional probability. The difference of the Bayes and the normal conditional probability formula is that Bayes formula is updating information. Something else arrived that will make you to update your information. That's why the Bayes formula uses a conditional probability in the formula. See, look at this. After the equal sign, I have a conditional probability. P of B given A. So P of A given B equals P of B given A times PA divided by PB. Right? Now, the conditional probability alone is just the probability of A given B is equal P of A and B divided by P of B. Okay? So the difference is that the Bayes formula uses a conditional probability to find the other conditional probability, and the conditional formula use the joint probability AB. Okay? That might be important for some of you. Now, I believe that in the exam, it's going to be specified for you if you're going to use the Bayes formula or if you're going to use the conditional probability formula. But definitely, if you're going to use the Bayes formula, you will be given on the problem. That's what I expect. But in case it's not, then look in the question. You see, oh, there's a conditional probability here that I can use to find the other conditional probability. That means you're going to use Bayes formula. Okay? All right. So let's see an example here how this works. So here I have a situation. We have economic stage, boom, normal, recession, and I have the probability of each one to happen. Okay? 25, 40, 35. And the probability of the EPS go down under each stage. So if there is a boom, 5% chances that the EPS of a company will go down, or that particular company you're doing the research. Now, if the economy stays the same, then there is an 8%. And given that the economy gets into recession, you get a 30% chances of the EPS to go down. So the first question is, what is the probability the EPS overall that the earnings per share of that company will go down? Well, it's the weighted average of those numbers here, right? It's a 25% chance of being 5%, 40% chance of being 8%, and a 35% chances of being 30%. So now you're going to have to kind of multiply and add. So that's called, I'm using a formula for Excel here that unfortunately you're not going to be able to use in the exam, but I don't think you're going to have to do long, extensive calculations like that in the exam. It's too time consuming. This times this plus this times this plus. Even if you put the storage and recycle, it still takes too much. Okay? And then here, and I'm going to close the parentheses, and the answer is, boom, 0.1495 is my the probability. So 14.95%, let's put it there, 14.95%, okay, is the chance of the earnings per share go down overall. Great. Now let's see the question here. Calculate the probability of recession given EPS is down. So look what you need. You need down here probability of recession given EPS is down. Using the Bayes formula, I know that the next after the equal sign is the opposite of the condition, the opposite conditional. So here is down given recession. Okay, probability of the earnings per share going down given recession times the probability of recession times the probability of going down. Great. Now let's look into the problem if you can find it. Good. Probability of going down given a recession. It's 30%. Right there. Okay? It's even given here. 30%. So put it there. Times the probability, I'm gonna even put it on Excel symbols here. Times the probability of recession. We just find it there. The probability of recession, it's 35%. Be careful, huh? 30% is the probability of the earnings per share going down given a recession. 35% is the probability of recession divided by the probability of the earnings per share to go down overall, which is my 14.95%. Okay, there you go. So on the Bayes formula, you're always going to need three numbers, okay, to find another one. It could be that they give you the two conditionals and ask you the probability of recession, or the two conditionals and the probability of recession ask for the probability of the earnings per share to go down. Anyway, they can be creative creating questions here. But the idea is that know how to use the formula. All right? So let's see how much we get here. Put an equal sign there. 70%. There you go. So the probability there is a recession, given that the EPS went down, it's about 70%. So that's the earnings per share kind of telling the financial analyst about the recession versus the recession telling the earnings per share. That's the idea here. This what you call the additional or complementary information. All right. So don't think that's too difficult. The Bayes formula is not too difficult. Now, if you understand that the essence, what you're trying to capture here, if you remember that you only need three elements to find number 4, right? 3 variables. Understand which one are they, and most likely you'll be able to perform well in the exam. Okay? All right. So that's it. That concludes my explanation here for the Bayes formula with a quick example. Okay? So just recap what we did today, okay, on this video. We did all those learning outcomes here. So let's see if I kind of like check mark them. Calculate expected value, variance, and standard deviation, their application. We did that on the previous video, so I'll give a check mark here. Formulate a problem as a probability tree. We did not formulate a problem here, because I believe that that's going to be out of the scope of the exam. But formulating a problem, if you want to practice that, you send the questions in the group. We'll help you in case that you're not finding how to find the answer for the problem. Explain the use of conditional expectations. We already said. Calculate and interpret investments and using Bayes formula. We already did it as well. The key points. Expected value and variance from previous video. Probability trees, check. Total probability rule is when we solve the tree. So that one checks as well. The Bayes formula, check. Great. That's it. That's the learning module number 4, friends. I'm here for you. Kind of like explained it. Now, I would definitely go and practice as much as I could questions on the ecosystem, because I believe that the chances of those questions appear in the exam, they are high, in my opinion, or relatively high, and the chance of the question being numerical rather than conceptual is higher. So I would definitely practice that. Okay? All right, so that's it. That's the end of this video, learning module, the probability trees and conditional expectations, right? So the next video will be on portfolio mathematics, right? It's another topic that will talk about covariance and correlation and other variables that are important in portfolio management. But that's on the next video. This one I'm ending now. Take care. Bye-bye.